At this point in geometry, we've talked about rotating a point around the origin, 90 degrees, 270 degrees, whatever. But we've also talked about rotating a point about a center that's not at the origin. And we've looked at a couple of visual ways of doing that from the center of rotation, like making a little L shape, basically, that has the horizontal and vertical components, and rotating that. Or we've also talked about using directions, like how far in what direction we have to go to get to that point from the center, and then adjusting those directions according to the way we are rotating. I want to show you two more ways of doing it that are kind of more about adjusting the big picture. Okay, so let me give you an example. Problem number 1 here. We're going to rotate the point 3, -5, 270 degrees about the point -1, 1. So 3, -5 is right here. That's my point A. And I'm rotating it about the point -1, whoops, 1, sorry. -1, 1 is my center of rotation. So here's my C. And we're going to have to ignore that dot. Sorry about that. And we were told to rotate it 270 degrees. So that's what we're going to do. So here's how we're going to do this. There's two different ways that sort of have more to do with adjusting the entire big picture, kind of like adjusting the grid. One is that I can think of the grid as actually being over here. Think of my X and Y axes. Pretend that they're where the center actually is instead of where they actually are. So I'm just going to think of wherever my center as being the origin of my new set of axes. And then I find the coordinates of my point with that center or as the origin. So that would be 1, 2, 3, 4 to the right, and 1, 2, 3, 4, 5, 6 down. So the coordinates of A in this world are 4, -6. Okay, so that would be if my center is the origin, where A is with respect to it. Then I'm going to use the rules that we use when we are rotating about the origin. We're really just pretending my center is the origin. So pretending my center is the origin, I figure out what the coordinates of that point would be, and then I use the standard rules for rotating about the origin. So if I'm supposed to be going 270 counterclockwise, that means I'm going to do y and -x. That's a comma. Sorry, I kind of had a typo there. Y, -x. So this is my x, this is my y. I'm going to change that to y, which is -6, -x. So I change the sign of the x. So 4, -6 changes to -6, because that's my y, and then the opposite of my x. So -6, -4 is where that's going to move. Now, again, we're still in the world where C is at the origin. So I'm going to go from the origin, -6, -4. So -6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, and it's right here. The last step is I have to take away the fact, the idea, the imagination that C is actually at the origin. Okay? Because the real coordinates of that point are not -6, -4. That's just how to get there from C. Okay, so I have to go back now and ignore my red lines and just think about where this point is with respect to the black, the actual x-axis and y-axis. And that's where this is the origin, and I go 1, 2, 3, 4, 5, 6, 7 left, 3 down, and so that is my answer, is -7, -3. And that's one way to do it. So again, I just drew a grid with C as the intersection of my horizontal and vertical lines and said I'm going to pretend we're in this world, do it just like it's around the origin, but then I'm going to, at the very end, recognize that this point isn't actually at -6, -4, and figure out where it actually is. That's one way of doing it. Notice that it's really kind of what we were doing before, in that what it's 4, -6 is going right 4 and down 6 to get to point A from C. So it's all about how far are we from point C. Another way of doing kind of the same thing is this. Let's see, my center is at -1, 1, and A was at, what, 3, -5, okay? My center is at -1, 1. And A is at 3, -5. Okay? Basically what I do is I say, well, what if the center were at the origin? But instead of drawing the grid over my center where the center is, I'm going to go do this. I'm going to move the center to the origin. So basically what I'm going to do is I'm going to take whatever coordinates the center has. The coordinates of the center are -1, 1. That tells me to go from the origin to the center. I go left 1, up 1. So if I want to move it to the origin, I have to reverse these both, which means I'm going to go right 1 and down 1 if I want to shift it like this. So that's what I'm doing. I'm moving the entire thing so that my center is now at the origin. So that means I'm going to take my point, wherever my point was. It was originally at 3, -5. And if this has to go right 1 and down 1 to go to the origin, this has to go right 1 and down 1 to go to the origin. So right 1, down 1 puts this at 4, -6. Notice that's the same place it was when we did it the other way. Then I use the standard rules, same rules as ever, and just like before, I'm going to get -6, -4, which is over here. I'm sorry, wait. -6, -4, 1, 2, 3, 4, 5, 6. I'm rattled because the bell rang. Okay, and now here, again, I have to go back to reality at the end, because that's not really where the point goes. So I have to move C back to where it's supposed to be. So right now this is at -6, -4. But C has to move back where it's supposed to be, which is -1 plus 1. So -1 plus 1, subtract 1 from this, add 1 to this, and there's my answer. So that's another way of doing this that may or may not appeal to you.